So we're being asked to, the sketch below shows the curve of the equation y equals x squared minus 2x minus 3. Find x coordinate of the minimum point M. Okay, so what we know about maximum and minimum points is at a minimum or a maximum point dy by dx equals 0. So to use this, we're going to have to differentiate the equation for y. So if we have a look again, just reminding you, our rule for differentiation is if y is equal to a times the power of x, then dy dx is you multiply by the power of x and make the power of x one less. Okay, so if we start with y equals x squared minus 2x minus 3, then if we differentiate that, it becomes dy dx equals 2, make the power 1 less, x to the power of 1, minus 2, and differentiate 3, it becomes 0. Now, if we set dy dx equal to 0, then we have 2x minus 2 equals 0, so clearly x has to be 1. So the x coordinate of M is 1. Part 2 then, hence find the area of the shaded region. Okay, now most of you will remember that the area of any curve between the x-axis and two x values a and b is given by the integral, the equation of the curve y integrated with respect to x between the limits a and b. So in this case our limits are going to be 1 and 3. Okay, so we've got the area is equal to the integral to 1 and 3. The equation for y is x squared minus 2x minus 3, and we're integrating dx. So again, if we have a look at our formula sheet, we'll see if we're integrating a power of x, what we do is we add 1 to the power of x and then we divide by that power. Okay, so in this case then we're going to get x cubed over 3 minus 2x squared over 2 minus 3x. Now because it's a definite integral, what we do now is we put square brackets around that and we write the limits on the top and bottom of the right hand bracket. Okay, so now what we do is we put in 3 to this expression. Okay, so it's going to be 3 cubed over 3 minus 2 times 3 squared over 2 minus 3 times 3. And then we take away, we put 1 into that. So it's going to be 1 cubed over 3 minus 2 times 1 squared over 2 minus 3 times 1. Now of course, yes, you could have cancelled out those 2's right at the start, but it doesn't matter. Okay, so working this out turns out to be negative 9, take away, and working out this bracket turns out to be negative 3 and 2/3. So if we do that, we get negative 5 and 1/3. Now, areas can't be positive or negative, but in the case of integration, if you actually find out that the area integration value comes out as negative, it just means that the area is below the axis, and that's what it is in this case. So the area is equal to 5 and 1/3 square units.